All right, so purpose of this lab is as follows. We want to investigate the relationship between position and time for an object traveling at a constant speed. All right, so if we're investigating the relationships between position and time, those are our two important variables. Okay, time and position are our two really important variables. Which one affects the other given this description of the experiment? We are going to mark the position of the cart every 5 seconds for 40 seconds. All right. So the time interval is selected by us. It's 5 seconds. Okay. We're going to do that. We're going to mark the position every 5 seconds for 40 seconds. Okay. So you guys can decide which one you think is manipulated, which one you think is responding. All right. I want you to keep in mind this statement. The longer I allow this experiment to run, the farther the cart will go, in order to help you decide which one is which. Okay, controlled variables need to be anything that could affect the speed of the cart. Okay, so you need to decide on a few things. I would say right now, first off, your first control variable is the speed of the cart. Okay, that has to be unchanging. Otherwise, this whole experiment doesn't work. Okay, if the cart accelerates, we don't get the kind of graph we're looking to use here, right? So we need a object, or a cart in this case, that travels at a constant velocity. Right? So we're going to run all these carts in the same place. We're going to go out to the atrium, right? And we're just going to run them down the hallway. All right. The way we're going to do this is we'll have a measuring tape, which I still have to run out and get because it's missing. I think I know where it is. I guess that means it's only misplaced and not missing, as long as I know where it is. Okay, so here's how we're going to work this. The measuring tape will be placed on the floor in the atrium. Okay, these battery-operated motorized carts, okay, will be released from a starting position, okay, and we will allow them to travel along beside the tape, beside the measuring tape. They do need to be steered periodically. All right, so the best way to steer them is just to give them light nudges with either your hand or your feet, okay, whichever, but we'll have a couple of drivers, okay, who will be doing this. All right, so you just fire them up. This one has really dead batteries. I want 4 carts that'll all go at different speeds. By the way, the carts are not a variable of any kind in this experiment. We're just using 4 carts so we get a little extra practice with graphing. Okay, we're not comparing the carts really in any way in this experiment. Okay, so this one's got really dead batteries, so it's going to go really slow. Okay, some of them have really good batteries. Some of them have really good batteries and stripped gears. Hopefully, they're all going to have slightly different speeds so that their lines don't overlap on the graph. Okay, so we're going to run these down the atrium. Okay, along the tape. We'll have a person who's timing on their phone and another person who will be placing these little yellow sticky notes on the tape, marking the position of the cart every 5 seconds. Okay, and then when the whole run is done, I'll walk along the tape and read out the numbers, and you'll enter them into your Google Sheet for each cart. Okay, so it's pretty straightforward. Now, are there some real major areas for error? Okay, so I want you to think about that. When we're running this lab, look for places where you think there could be sources of error, because obviously you'll want that for the evaluation portion of your lab report. Okay, so be on the lookout for that. All right, so that takes care of the design part. For our hypothesis, we want to generate a hypothesis about the relationship between distance and time for an object traveling at a constant speed. All right, we haven't talked really about the different relationships on a graph yet, so I'm going to quickly talk about that. Okay, the different relationships are linear. Okay, that means that as the manipulated variable increases, the responding variable increases at an equal or at least linear rate. Okay. There's exponential relationships. Okay? Exponential relationships involve an exponential increase in the responding variable with an increase in the manipulated variable. So if I doubled the time, the position would increase by a factor of 4. If I triple the time, the position would increase by a factor of 9. That would be an exponential relationship. Okay, everybody follow me there? So you get a curve on an exponential relationship. Okay, this is an inverse relationship. As the manipulated variable increases, the responding variable decreases. Okay, it's inverse, but it's also linear. Okay, this would be like a positive linear. This is an inverse linear. Okay, and then there is inversely exponential. That means that as I increase the manipulated variable, there's an exponential decrease in the responding variable, right? So like sound, intensity of sound is an inversely exponential relationship. If I double my distance from the sound, it's 4 times less loud. If I triple my distance from the source of the sound, it's 9 times less loud. Okay, it's an inversely exponential relationship. Okay. All right, so those are the ones that we would see, okay, in Science 10. Which one do we suppose is true for what we're doing today? Linear. Okay, good. All right, so in our hypothesis then, we would want to stay in the if part, okay? We would want to say what kind of relationship there is. So if, okay, we just said it was linear, so kind of giving you that. There's a linear relationship, okay, between this and this, okay? And describe the experiment same as always, okay? Then I want you to tell me how you could calculate velocity from the position time graph. And we learned how to do that yesterday. Okay, so the then part needs to tell me how you're going to do that. All right, so once we've gathered the data, then it's just a matter of filling in the Google Sheet, building the graph, which I'll run through again, okay, once we have the data, and then answering the analysis questions, okay, and they're fairly straightforward, okay, there's things that we did just the other day, so that should all be familiar. So what I'll be looking for in terms of data, I'll be looking for your data chart. So you'll copy and paste that over from Google Sheets. I'll show you how to do that. Okay, and your graph, copied and pasted over from Google Sheets into the doc. And then the answers to your analysis questions. If you need to show calculations and you don't want to do that by typing them out, take a picture of them and insert the pictures into the lab report, same as you would have with your lab diagrams. Okay, just insert the picture of your calculations instead. For the conclusion, okay, copy paste your hypothesis, explain why it's right or wrong. Okay, evaluation is your sources of error, and we'll talk about the class discussion questions when I hand back the labs. Right? Questions on what we're doing here? All right, I'm going to give you a couple of minutes to get the variables and hypothesis all written up, and I included the Google Sheet for you already. Okay, so it should look like this. We're only going to have 4 carts, so you won't need cart 5's position, and I've already put the times in. So that's all set up for you. So just work on the variables and the hypothesis for right now while I run out and grab the tape measure. All right, so this is not the same data that you guys have, but it would take me too long to copy all the data down. So I'm just going to show you what we want to do here. Make sure that your graph your chart, looks like this. Okay, make sure that you don't have any letters like M's beside any of these numbers, right? Because Google Sheets will get confused. It won't know whether it's alpha or numeric, okay, and it won't know what to do when it comes to graphing it. So make sure that you only have the meters at the top here, right, when we're labeling. Okay, so now, first thing you want to do is copy your data chart into your lab report, right? So to do that, you just click and drag, okay? Highlight the whole thing, right? Control C to copy it, then go over to your lab, and it says here in procedure, copy and paste your Google Sheets table and graphs here. All right, so I'm just going to delete that, and Control V. Okay, it'll always ask, do you want to link it? You do. because if you make any changes, they're automatically updated in your lab report. You don't have to recopy it. Okay, so always click linked. All right, so now my graph, my chart is in there. So that's good. Now I'm going to go back to Google Sheets and I'm going to build my graph. Okay, so to build the graph, I keep all this stuff highlighted and then I go to insert. Okay, I scroll down to chart. All right, and then of course it gives me all kinds of bad options that I don't want to use. All right, so I don't want column chart. I'm going to click on column chart and scroll down till I find scatter. Okay, so right now this is looking pretty much like we would want it to look. Okay, the only thing is we got to fix a couple of the, like we don't have a label over here, okay, on the y-axis. That title makes no sense at all, so we want to change that. Okay, we don't even have to really alter anything in terms of the things that are clicked. Everything that's checked, we want to leave checked now because that's going to work out the way we want. All right, so we're going to go over to customize and fix our title first off, because cart 1 position M, cart 2 position M doesn't make any sense. All right, we're just going to call it position versus, oh. Okay, so we'll change that, and then I'm going to also put on a vertical axis title because there isn't one. They did the horizontal axis fine. Okay, so the vertical axis, what's on the vertical axis? Position, right? In meters, make sure you have the units there. Okay, so now we're good in terms of how it looks, although I don't really like where the legend is. Okay, I like putting the legend over on the right-hand side. Okay, that's up to you. It'll look better when you have the equations in there. Okay, then we want to go to series. Okay, and I would say you probably want to change the point size on this one because you have a lot of data points on here. So change it from 7 to 2, and they'll get a little smaller. They don't overlap as much that way. And then if you wanted to, you could actually change what the point shape is for each series. Okay, so, but before you do that, click on that you want to add a trend line for all of them. Okay, so click on this box right here where it says trend line. Okay, now it draws a trend line for each of the sets of data. Okay, we do want it to be linear, so it's already selected that. And then down here at label, I want to click use equation, so it'll spit out an equation for each line. Okay, so now I have those. All right, now what I would do if I want to change the point shapes, okay, is I go back up here to where it says all series, and I'll leave cart 1 as circles. Cart 2 I'll change to diamonds, and cart 3 I'll change to stars, and cart 4 I'll change to triangles. All right, so now at least like if I blow up my graph, they'll look a bit different and it'll be easier to keep track of. They're also color coded, but all right, so now that's basically what we need out of our graph. Okay, the graphing part is done. I can close the chart editor now. Okay, and I just want to copy my chart, okay, over to my lab. So I'm just going to copy the chart, go back over to my lab. Okay. I want to link it just in case I need to make any changes to it later. And my graph is in there. And I can make it bigger, which probably isn't a bad idea. Okay, making it nice and big. Okay, filling up the page is a good idea. All right, so now you just have to do the analysis. Okay, that's all the data stuff there is to do. Now you got to answer the analysis questions, show the calculations. All right, so for analysis question number 1, it says show how you would calculate the slope of each car's line on the graph. Okay, that is show me y equals m times x plus b manipulated for slope. Okay, so what that means is, okay, that somewhere in that question, I'm going to want to see you manipulate the equation. Okay, so It says y equals m times x plus b. I'm going to want to see somewhere in there, this thing changed, so it's m equals whatever. Okay, I just need you to show me that you know how to manipulate that one for m. Show that manipulation. Okay. Then for question number 2, says using the equations for each car, calculate how far each car would travel in 150 seconds. All right, so you need to solve for essentially the final position. Okay, that would be the displacement in this case because they all started from 0. Okay, for each car after 150 seconds. And then question number 3 is similar. Okay, using the equation for each car, calculate how long it would take each car to travel 100 meters. So that's these equations here. Right, the ones that Google Sheets spit out. Okay, manipulate those so that you're solving for what those questions ask for. Show me your work. All right, so you can either type it out, which wouldn't be all that hard for these calculations, but if you'd rather write it on a sheet of paper and take a picture, that's fine, but I need to see the work for each car. Okay, for question 2, each car for question 3. Okay, and then you got your conclusion and evaluation after that. Any questions on the expectations?